On the occasion of the United Nations World Day to combat desertification and drought, I'd like to welcome everyone to this session. My name is Swapnil and I'm from Pune, India. Starting with the agenda, the first part of the session will cover the context of the theme and World Drought Day on a worldwide scale. The next step would be to understand the Indian subcontinent's trends and challenges in this regard. Following that, we learn how the Ministry of Water Resources has developed a national policy and regulatory framework. Then, we look at how a project is implemented on the ground based on this framework and how the regulation determines the outcome. Finally, we'll conclude with the following actions we need to take to address the impending problem in a systematic way. So, why a day for combating desertification and drought? Drought and desertification, which began as a localized concern, quickly became a global challenge. More than just altering rainfall patterns, the situation has been compounded by agriculture and industrial revolutions. The United Nations created a convention in the year 1995 to address the causes of drought, with a goal to raise awareness, combat the problem, mitigate the impacts, and recovering from the disaster quickly. Last year, the conference stated that no country, no country is immune to drought. And drought is one of the harshest natural disasters in terms of human life, food security, mass migration, economic damage, to name a few factors. 17 June is observed as a day to combat desertification and drought since then. With this context, the conference proposed a concept called as the Drought Vulnerability Index. This was to raise awareness, and a report was published earlier this year. It indicates the probability of a drought occurrence in a certain geography. It studies various factors such as changes in climatic pattern, increased industrial activity, urbanization of undeveloped land, and some more. It is increasingly evident that the countries lying in the equatorial belt, in this region, they are the most vulnerable to drought. However, this calamity has recently swept to the tropical belt as well, and India falls in the tropical zone. India is very likely to experience severe drought events in the near future because, as we know, water stream or a river does not have geological bounds. It may meander through any terrain and may not return. Observe this scale on the left, starting with less vulnerable to more vulnerable. And India right here lies in the more vulnerable side. So we are not far away from a severe drought. Now, moving on from general global trends and challenges, we will look at India's scenario. So, what is a drought in Indian context? Monsoons and melting Himalaya snow caps, they are the ones who replenish the seasonal and perennial rivers, which forms the water ecosystem of our country. Inland monsoon showers, they replenish groundwater. So in India, the primary sources of water which help the Indian economy are mainly two. First, surface water, and second is groundwater. And the ratio to which we utilize these is surface water contributes to around 30% of our annual needs, and groundwater contributes to a staggering 70%. So groundwater is a major source for India. And indirectly, groundwater contributes to around 70% of India's economy. This is one more fact. India is one of the largest areas dependent on groundwater. Now, the standard definition of a drought as per the Indian Meteorological Department is any area which has a rainfall deficit more than 26% of its long-term normal is declared as a drought. However, in this definition, the accountability of groundwater is not very explicitly calculated. When you visualize a drought, an image, what you see on the right here, comes to our mind, a parched land. These are satellite photos of California's Folsom Lake. This is one of the most covered drought topics across the globe. Drought in layman's terms is defined as shrinking water bodies, river banks narrowing, declining groundwater levels, and eroding of forests. These are some of the key indicators that we observe during a drought. During usual periods when we don't have a drought, the amount of water that we receive as an individual user of water, the quantum of water could be anywhere between 125 liters to 500 liters per person per day, which is more than enough for our day-to-day needs. But when a situation like a drought occurs, this comes to as low as 40 liters per family. So from 125 liters per person, and for a family of five, it is around 600 700 liters for a family. It comes down to as low as 40 liters per family. This is what happened on day zero in South Africa. This is an image of a perennial lake in Chennai. So drought does not look very different in different parts of the world. Shrinking size of water bodies in this zone alone in Chennai impacted 40 lakh people in the urban population and industry likewise. Coming to Maharashtra, this is an image from Maharashtra when the state had declared drought in over 25 districts in 2018-19. As a result, groundwater is a vital resource and the final straw until next monsoon arrives to battle the drought. And all we can do is only hope for a good monsoon. So when there is no surface water, when surface water dries up, the topsoil layer crusts over to protect the groundwater from further erosion. This leads to something called as desertification. And the land appears somewhat like this, which is the end point of a drought. We have no other option than to rely on groundwater stored in subterranean water reservoirs known as aquifers. So this is another report published by the World Bank. As I said, India's area is highly dependent on groundwater, whereas India is also the largest extractor of groundwater. Of the total groundwater extraction across the globe, India's contribution is over 1/4 of that. It is 26% of the global extraction levels. And to put a number to it, there was a report published by the ministry. It says that approximately 253 billion cubic meters of groundwater is extracted. Now, this is not surprising since our surface water bodies or surface water streams, they dry up in the late months of winters or early months of summers. It is after that point we start extracting groundwater rampantly. And this strangely coincides with a few more significant events. Let me share some stats. So narrowing down from the global trends to India, now to the state of Maharashtra. So according to the government statistics and data compiled for over 50 years, extreme drought occurrences in Maharashtra have surged sevenfold. If you notice here, in the 1970s, the decade from 1970 to 1979, there were 11 extreme drought events in Maharashtra. And over time, in the last decade, in 2010 to 2019, the total number of events was 79, which is staggering. Maharashtra is regarded as one of the most prosperous states in the country with highest rate of development since industrial revolution. And in any given year, the state attracts over 1 million workers, students, pilgrims, and many more people within the state. The water reserves have decreased over time to the factor of say 7, whereas the water usage due to the increasing development has increased to the factor of maybe 10 or even more, which is why this topic is of absolute concern for our state and specifically for industries. Now, the reason that Maharashtra is called as a developing state, it is because there are around 40,000 registered industries within the state. And among that, Pune, Aurangabad, Nasik, Ahmednagar, Kolhapur, they are some of the most industrialized cities since they have a very solid economic infrastructure. Followed by agriculture, industries are the second largest consumers of water and they also have a largest footprint. Unfortunately, these very developing industrial zones are declared as hotspots for a drought occurrence in the near future. And this data corroborates with this graph. So learning from the past data and series of such events, there was an action plan being driven by the central ministry. So with this context and learning the severity of the problem, the ministry played a very pivotal role in combating the calamity in a decentralized fashion. It is only then that the problem can be addressed and mitigated at a considerable scale. So, just to give you another fact, oil was struck in the year 1889 in India at Digboy. At the time, a barrel of oil costed 94 cents, and as on today, the cost of same barrel of crude oil is around $110. So it is approximately 11,000% appreciation in the monetary value of oil. Let's park this thought aside and come to groundwater. Groundwater, likewise, was first regarded as a resource in 1882. So this is the timeline of how groundwater, once it was realized as a resource and to what it is now. It was owned by the landholder and had absolute control over it. Central Groundwater Board was established in the year 1970, citing the need to protect and develop groundwater. And they developed policies and programs. Groundwater, which was free, was identified as a public resource and charged anywhere between rupees 1 to rupees 10 for a cubic meter. And water will soon be traded in the futures market as well. Now, do you see any synonymity in the journey of crude oil and water? Water, which was earlier not charged, until very recently it has been charged. So the appreciation, the value, monetary value of water has surged at a much faster rate than what crude oil has covered in the past years. So the Central Groundwater Board, it identified commercial establishments which buy water from local authorities. A model bill was passed in the year 2011 to drive action towards protecting nature from water scarcity events. A sustainable management bill was taking shape for implementing solutions on ground. And this is where the Central Groundwater Authority's NOCAP compliance took shape. In the year 2015, the Central Groundwater Authority issued a notification in conjunction with the National Green Tribunal to commercial establishments like infrastructure, mining projects, infrastructure projects. It is estimated that over 80,000 industries fall under this notification in the west zone of India alone. Based on this notification, geographic areas were identified. They were categorized as these: overexploited, critical, semi-critical, safe. So this was on the basis of natural water reserves in that geography and the water consumption patterns. If you see here in this diagram, over a third of these zones fall under semi-critical, critical and overexploited zones. Now let us look at Central Groundwater Authority's NOCAP compliances, starting with the phases from documentation to implementation and impact. So for the ease of understanding, I've illustrated the steps from policy to outcome in these manner. So followed by the notification to the industries, the action plan was something like this. First was to regulate with the help of policy, regulate groundwater or regulate water consumption with the help of policy. Second was control the usage on the basis of zones like overexploited, semi-critical and others. Third was to identify and develop groundwater by implementing solutions at those very locations. Fourth was, after successful implementation, the impact of the project is monitored with water consumption data and groundwater level data. And finally, documenting the results and maintain the project for its usable lifetime. So until this point, what we covered and understood was what is drought and why a day for it, what it means in India's context, how the ministry has developed and driven a top-down action plan, a framework in the last slide prepared for implementation in a decentralized manner. Now we will look at a practical case study of how this policy has driven action and we have seen measurable results. We'll come down to a localized solution at that level, coming down to Maharashtra, narrowing down to Pune as a case study. Now, if you notice, this is the center of the Pune and these are some of the projects that we had delivered in these terrains. Now, this red belt that you see, if you draw a circle from the center of the city, starting at 30 kilometers and ending at say 80 to 100 kilometers, these are the areas where we have industrial clusters, where industrial development actually happens. They are away from the central urban cities. It is called as a semi-urban area. And these are the areas which are heavily dependent on water for their manufacturing needs. So, as a practical case study, we will look at one of the sites in the eastern part of this belt. So, this was one industry located around 60 kilometers in this zone. We learned that In this area, if you notice the perimeter outside the facility, it's a drought prone zone. The industry is located in a semi-critical zone as identified by the Central Groundwater Authority. The annual rainfall here is around 200 to 300 mm. So the facility received notification in around 2017 and it proactively took up the implementation. So as per the guidelines, what we started with was we channelized whatever rainfall was incident within the property. It had not to be let out of the property and groundwater had to be developed. So the steps included a groundwater recharge system, groundwater level monitoring system, and understanding the water consumption, that too monitored with a remote telemetry system. So when we started, we identified this area. This was worthy of holding water. Majority of the water that was incident on the property during monsoons, it was channelized to this point. It was cleared. We studied the hydrogeology. We built infrastructure to tap the water and help augment the groundwater naturally. We created recharge channels within that premise. We deepened the level of that place so that it could hold water naturally. And after a year of monsoon, the hydrology of that particular terrain started to retain water. Though it wasn't visible on the surface, it was something like this. The ground was actually started getting saturated and the water level started to rise up. And this was result after 2 years. So the recharge shafts that you see here, the water levels which are otherwise not visible, and even in the background if you see, the terrain is quite harsh. It does not retain water very easily. We could see water levels rising from very deep levels to very shallow levels. As a part of monitoring and data gathering, we started monitoring water levels on a real-time basis with the help of advanced digital groundwater level monitors. The levels were assessed periodically. This was an instrument fitted for that. The digital instrument showed gradual rise of water table, which was a key indicator that an implemented project was starting to show results. Next step was water consumption was also being monitored real time with the help of digital flow meters, which communicated remotely with a telemetry system. And lastly, the most encouraging result was this. This was one of the case studies which showed us very positive results. Likewise, we could implement many projects in the years to come. Results vary from site to site, but let me share a summary of a few. Outcomes of this notification are well monitored and measured everywhere. So some of them are 120% increase in water availability even during seasons of lesser rainfall, up to 80% reduction in dependency on outside water sources, enhancement in water quality and thereby rejection of fresh water during treatment of water for process, and about 30% saving on production losses which could occur due to non-availability of water for process. So these were measurable outcomes and these are corroborated with the data that we have gathered, and the results are very encouraging. So I'm thankful to frontrunners like John Deere, WordGain, Seco Tools, who have contributed in their capacity to mitigate this challenge up to a great extent. The project implemented at this very facility was even addressed by the groundwater authorities as ideal implementation on ground with notable results. Different facilities have experienced different benefits. This was one facility where the yield of groundwater in that facility increased almost 5-folds, which is documented. And don't just take our word for it. Industries are reaping benefits out of this. As a way forward, what we have learned in the past 10 years of our experience, that if this solution is implemented in a decentralized manner, if the basics are done right, if the system is designed in a proper way, the industries have reaped benefits out of it. But to go ahead to the next step of this, what we recommend is solution in a clustered manner. So decentralized yet a clustered approach. Notification that the Central Groundwater Authority has devised, it has a robust action plan. It is not just a compliance or any other regulation. It is an outcome-oriented plan with measurable outcomes. And industries have footprint of anywhere between 10,000 to 10 lakh square meters with a very good infrastructure to channelize all these efforts. And hundreds of industries have demonstrated these results. So what we are proposing is a cluster of say 5 industries. If they fall in a particular geographical belt, say it is a semi-critical or a critical zone, if they come together and implement something like this, it can surely mitigate the drought issue by a great margin. So as I said, the key takeaway here is clustered implementation. In the previous slides, what we saw that the industrial zones which are struggling or which are likely to be the hotspots for drought, they can turn into drought-free zones. And we have already been able to demonstrate this in and around Pune. So one industry could see benefits in their own capacity, and they were the prime beneficiaries of the system. Imagine a group of industries coming together, what impact it would create. I believe we can cut down our dependence on water that is sourced from dams and lakes which are miles away from where we are. Water is sourced from all these places. So I believe we can cut down this dependence as much as 45%. So that is the message for the day. Implementation of water conservation in a decentralized and clustered fashion for industries. And yes, together we can combat drought, we can overcome a drought like this. So to summarize today's session, putting it all together, we started with context of the World Day for Drought, addressing trends and challenges in the Indian context, action plan which is policy driven, and the CGWA NOCAP compliance for industries, case study of an industry which has faced success, and the way forward. So I'm thankful to all of you that you have attended the session. I'm very sure that we can change a situation which is something like this to something like this, which is very much possible. And on a closing note, I would like to share this is our vision to make India water secure.